Coming up on the FTC Open Alliance show. We're nearing the end of the FTC Open Alliance show, but we brought back a great team, 23513 I.N.T Robotics from New York. They just had a huge qualifier win last week. They set the state record in New York as well, too. So we diving more into their experience of competing at an event, what they learned from it, especially from a competition standpoint. And they'll be talking more into their 2.0 robot. Some of the new designs they'll be doing. We'll be diving more into the CAD of that design and the upgrades. Why are they making those changes and what they expect to see out of those changes as well, too. So let's learn more about them coming up here on the FTC Open Alliance show. Let's welcome back into the Open Alliance show, 23513 I.N.T Robotics coming out of New York. They just had a huge qualifier win last month, so congrats everybody on that. And a lot of great stuff to cover as well. If you don't mind, why don't you reintroduce yourselves, and we're going to get right into that event recap and what you're finalizing.
Okay. Hello, my name is Rachel Kim, and I do electronics as well as design on I.N.T.
My name is Darius. I'm one of the captains and electrical and programming.
My name is Andrew. I do CAD design and mechanical.
My name's Esther. I also do CAD design and mechanical.
Hello, my name is Ellen Kim. I do CAD design and electrical.
So you just had a huge win a month ago. Let's talk about, from last video coming into here, catch us up on what your team's been doing.
Okay, so a lot of improvement, a lot of changes have been made since the last video. Last video, we only had a drivetrain and everything else was pretty much off. Well, we still had none of the mechanisms were really, besides the arm system, were really finalized. As you can see, that one of the first things we changed was actually the whole intake system. We went from our active claw design to now just solid like state claw. Andrew can explain more on that, on why we changed it. And after that, we can talk about what we actually did to make the carbon fiber spool viable for competition.
Yeah, so we had a lot of issues with the carbon fiber spool. One of them is just it wasn't having a smooth extraction. So every time we had to go out, it would become really clunky. It would get stuck. There was a lot of friction. So the first change we made is we made this bearing hole larger. This way we can have the way that the carbon fiber conforms. We can have that be a little bit best fit for the carbon fiber spool. Then what we did on the back of the robot was we have these in the back, these rollers, and we actually spring loaded them. So this way it adds like constant pressure. Even if the arm is extended further out, there's still constant pressure being applied to the arm. And it was a great help to us because without this, we wouldn't really have proper spooling when we were at greater lengths or when we were at the most compact form. So that was really one of the biggest changes we made for the spooling system. Then back to the intake. So we had our original active intake that we changed for this more of a claw type intake. It still has a pivot and swivel and everything for that. But the reason we changed it mainly was due to weight. The active intake worked well for intaking the pieces, but it just had too much weight as we extended the arm to our max reach, and it would just kind of start drooping down. And that was just something that we couldn't really handle having on the robot. So we switched it for something more lightweight, more compact, and this turned out great at competition.
Yeah, so we can get the video of us actually like intaking and scoring up. Another thing is that from a programming standpoint, especially taking auto into consideration, because we were more lenient towards the specimens, especially in terms of autonomous. I wanted to have something that was like easily reproducible and reliable, and so we figured that having something that isn't ambiguous, we don't have to like time how much we're rolling out, rolling in. We just know, is it open or is it closed? It was much better, and in fact, it ended up being better for our autonomous, but. Yeah, other than that, having these retractable bearings was really what allowed like reproducibility in our actions, which was the most important thing because that's what all of our autonomous routines were contingent upon. And other than that, one other change that we made is that we used to have acrylic, blue acrylic hooks, and instead for climbing, which we also have a video on, we changed it to aluminum because reflecting on competition, our greatest advantage was that we didn't have to take like 10-15 seconds to climb during endgame. Our climbs were literally between the 2 and 5 second ranges, and having aluminum hooks means that we could just, from whatever distance we could just slam onto the metal bar and just retract ourselves up without having to worry about like the integrity of the hooks or anything like that. And speaking of competition, things that didn't work out, Andrew can talk about these hooks a little bit.
So we initially intended to be able to go for the highest level ascent. And in our first video, we had hooks on the top of this aluminum piece that were built into the drivetrain panel. And that kind of backfired at competition where we had a match where we actually got stuck on the wall due to hooks because they were just at the right level that they would get caught on the wall perimeter. So after that, we chopped them off and we didn't have that problem again. But since we weren't even utilizing the top level ascent, because for our strategy and gameplay, It wasn't something that we thought that was necessary for us to get the max amount of points. We focused more on scoring, as you can see on the poll, instead of going for the level 3 ascent. This way we got our max points. But it was definitely a very spontaneous change that we had to make during competition. But it greatly affected us. This way, it reduced a big risk for us during competition.
Yeah, and just going along with what you're showing right now, that's right now our 0+3 autonomous. Um, and just in regards of that, we have three odometry pods. We originally wanted to use the odometry computer, but we decided to just since this was our earliest qualifier, we wanted to stick with what we were used with, which is just the three pod setup. So we went with that. This was just like rough tuning, like 2 to 3 days worth of tuning, and we found that the results were pretty reproducible, especially because of the fact that the clock can extend so large when we're actually picking stuff up from the human player station with micro adjustments that can be made before we enter the tape. We were able to get like almost 100% accuracy, and it wasn't like the only things that really failed on us, which is why I want to improve upon the carbon fiber system with our new Mark II robot, is the fact that the carbon fiber over time it degrades. That's like the biggest problem that we noticed, because right now what we did to the carbon fiber spool is that we had to cut like a 6-inch section out of it, because after like repeated using of like from weeks, starting from robot in 3 days, we noticed that the motors would physically stall if it tried to extend past a certain range point. And so we basically had to like cut it down to length. And we notice right now when we try to reproduce the same movements that we had in competition, the quality has gotten worse and the motors have started to stall up again. So we eventually want to have a robot that can obviously last across multiple competitions, which is why we want to move away from the carbon fiber like whole spool design and switch over to something more traditional with a slide setup, which is why we can start talking about just the core of what Mark II is going to be about of our system.
Well, before we get into that, I do want to ask you guys. So, coming from your first qualifier, Ben, we have one of your matches on screen, which at least as when you competed, this was the New York State record as well, too, which is awesome. What are maybe some key things that you learned from competition at this first qualifier? They're like, either match strategy wise or something else that you're going to implement into your next event.
So I think one thing that we really started this time around was a formal scouting system. So we actually started collecting data on a lot of our matches, and that kind of helped us pick for quals. So I think that was just something that we're definitely going to try implementing and fixing a little bit next time.
And maybe the most important part is just synergy between teams, because well, I do believe it's important for both teams for like a good well-rounded robot to be able to be good at specimens and actually just samples into the bucket. What the trend that I see most consistently is that there will be a team that primarily focuses on hanging on the specimens, and a team that primarily focuses on doing the samples. So just figuring out like where does your teammate fit in. We think we had a really good alliance, because we were being like very specimen dominant during the whole competition, and we're able to be partnered up with someone who was like mainly bucket focused. And our biggest advantage during strategy is that instead of going to submersible and dropping off to human player, waiting for him to clip it on, just doing that like one-on-one motion, is that what we did is that we grabbed like 8 or 9 specimens during like the first minute of teleoperated period. And then after that, by that time, we like the human player would already have like 6 to 8 of them hung up. And like during the last 45 seconds, 50 seconds, just back to back to back scoring it. So even though we'd start at like a point deficit, within the last 30 seconds plus like our like 5-second hang, we get like an 80, 90, 100 points gain just within like that last half a minute.
Well, let's talk about this Mark II robot and what some future plans are for your team.
To start off with our drivetrain, we realized we wanted more structure on the base, so we added 2 U channels, if we see here down here, so that the torsion forces can be less affecting the main belly plate. Additionally, we also wanted to change the gear ratio of our wheels to the motors that control the wheels, the mechanism wheels. So we're planning to use custom 3D printed pulleys to change the ratio so that we have less torque but higher speed. So hopefully this will be able to help us during our matches. Third, we for the drivetrain, we try to incorporate all the motors down as possible to lower the center of gravity. So this includes the ones that are used for all the elevators. And next is Just to mention that we also start incorporating like using on-shape to for this Mark II robot. So we combine both fusion and on-shape. And to add on, we kept the sprocket and chain for the pivoting part, but we said change to a generic slide elevator. But we were choosing between a belt and a stringed elevator. But we said go for a string because it was easy to belt the indirectly belt the spool so that the motor can be on the drivetrain. However, the spool can be on the shaft of the pivoting part if you see there. And we also added a linkage. If you see there, it's a passive linkage where it supports the elevator in two places when it intakes as well as when it scores. And we made sure the linkage does not fold over 90 degrees so that the linkage can only stay on the side where it intakes in. So now the motor for the pivoting part will not be stalling even when the elevator reaches max height. And if you see the pivot, the linkage does not go fold underneath because there's small hooks. If you zoom up to the part, there's small hooks that holds the pivot part. As well as for the climber, we got inspired by 694's Excelsius 2022 bot, where the climber hooks have surgical tubing on the back, so it's has a tendency to stay in a certain place. But if you push down against it, for example, if the robot goes against the wall or hits against the climber rungs, it would stay in place and pop back. And as we'll continue on with the also to mention about the sprocket and chain, we incorporated FRC drape shafts in order to have more structure, and so we also use drape bearings, and hopefully this will be able to provide more structure and be better off for the whole pivot and chain system.
So moving on to the slides, what we originally had was a 4-slide mechanism. And the reason we had to add another slide was just because of the linkage. We were limited to how high we were able to go. So then we had to add another stage to compensate, and that kind of changed our mounting mechanism, which Ellen will zoom into right now. And if you see, we have the servo motors placed on the inside of the plates. In our original design, they're placed on the outside. But those lead directly to a couple of compound gear trains. Simple gear trains. And we can see here is we have a gear ratio on both sides of about 1.5. And this just allows our whole arm to pivot back and forth like this. And then on top of that, we also have our claw. And on our claw, there are around 3 servo motors. There's one servo motor to open and close the claw, which is the one right here. There is another servo motor right here, which is connected to something that to our claw, which rotates around a single axis right here. And then finally, we have one other motor down here. Let's see right here, and that basically allows our entire claw to actually pivot. So we have a couple of degrees of freedom that we implemented for our Mark II design.
So I want to ask you a little bit, in terms of when you do rebuilds for your team, initially when you build a robot, you kind of come up with like objectives, like I want to do this and I want to accomplish this with that. How does that apply from a strategic standpoint when you do rebuilds? Are you looking at like, hey, I want to do this many more cycles, or I want to accomplish this, therefore we're designing this? How does some of that discussion and process work for your team?
Yeah, so in all my previous years, I've always done a rebuild whenever we go into a competition because after our first competition, like we had our qualifier one, we saw many problems that we wanted to address. So we saw things that we could improve upon from this robot that we can create another robot that can address all those issues. So one of them was cycling speed and just like intaking in general. So having a smoother transition from intaking to dropping off to then intaking from the wall, that entire cycle time, we can cut that down by creating faster, more efficient slide system compared to the carbon fiber arm. So we have different objectives we want to pursue when we go into a new competition that we can pretty much cut down all of our cycle times. Even if they're small amounts, it's still better than continuing with the same robot that we know we can't really change too much on. So we decided to start a new robot where we can take everything we've learned from competition, see how the actual game plays out. We might notice that something isn't as useful as we thought it may be, or we might see something that we never even thought about before. So doing a whole redesign is something really good that we think a lot of teams should do because it just helps you start like a fresh new slate after seeing the entire competition play out.
And for your team, when is your next competition or your next qualifier taking place? Where are you at, or are you going to states already?
So our next qualifier is on January 26th.
Okay, so you got a bit of time to still get that rebuild done and stuff. So we really look forward to, how your robotic course does. Of course, after a great qualifier win, high expectations, I'm sure, for the next one. All right, well, 23513. Thank you so much for taking time to show us these updates. Congratulations once again on your big win, and good luck throughout the rest of the season. We wish you the best.
All right. Thank you.